I'm going to start out in the book doing the area homework just because I copied it from the book. So let's see, you have to do 9, 10, 11, and 15. So let's start with number 9, triangle ABC. So I will draw a little triangle. Notice it's not perfect, it's far from it, but still draw a little picture. And they tell me that B is equal to 14.6, C is equal to 12.8, and the measure of angle A is equal to 56. I want to find the area. This is perfect for area because I have 2 sides in the included angle. So my area is going to be equal to 1/2 my 2 sides. So A, 1/2, and then my 2 sides are B and C, and then I'm going to do the sine of A. All right, 2 sides in the included angle. Then we plug in, this is going to be 1/2 times 14.6 times 12.8 times the sine of 56 degrees. All right, and you might be thinking, sine of 56, that's really weird, I don't know that, but the directions tell you to round to the nearest tenth, so you are going to get some crazy decimal, and you can just plug that into your calculator. Bingo, bango. All right, number 10. 10 gives us triangle ABC. We're very creative with our naming in mathematics. Here's A, B, C, little b, little a, little c. Remember, the smaller letters are across from the angle that are the capital letters. And little a is equal to 326, little c is equal to 157, and angle B is equal to 72. All right, you might be looking at that and saying, that does not look like a 72-degree angle. That looks like maybe a 90 or even an obtuse. Doesn't matter. All right, just draw the picture. Does not matter if it is accurate. So I've got 2 sides in the included angle, so my area is going to equal 1/2 AC times the sine of angle B. 2 sides, included angle. That's going to be 1/2 times 326 times 157 times the sine of 72. All right, and again, round to the nearest tenth. Easy peasy. Boop. Number 11, triangle DEF, changing up our variables. D, E, F. Here's little b, little e, little f. Little d is 5.83. Little e is 5.83, so I'm working with an isosceles triangle right now. Woo. And little f, big F, angle F, is 48 degrees. Area, 2 sides in the included angle, that's fine. Area will equal 1/2 the little b times little e times the sine of F, which is 1/2 times 5.83 times 5.83 times the sine of 48, which you can plug into your calculator and round appropriately. Just for funsies, since I know that this is an isosceles triangle, I know that these sides are equal, which was given to me. That also means that those angles are equal. So I could go one step further and figure out like everything about this triangle. Because I could figure out these 2 angles by doing 180 minus 48, which is going to give me 132. And then I could divide that by 2, and that will give me 66, I believe. 132 divided by 2. That goes in there 6. I'm left with a 12. Bring it down to 1, 2. 2 goes into 12. 6 times 66. So these are going to be 66 degrees. And then I could go ahead and use the law of cosines to figure out all those other sides. The problem doesn't ask you to do that, but it is good to see that there are, there's more than one law that we can use with these triangles. And last but certainly not least, we had to do number 15. They give us an equilateral triangle. So A, B, C, little a, little b, little c, and it's equilateral, so I know all the sides are equal. I also know that all the angles are equal. They are always equal to 60 in an equilateral triangle. And I want to find the exact value of the area if the length of one side is 40. Well, so if A is 40, that also means that P is 40, and that also means that C is 40. So it doesn't really matter. I can do that the area is equal to 1/2 AB sine C, or that would be the same thing as if I did 1/2 BC sine A, or I could do 1/2 AC sine B. Totally up to you which one you want, because they all mean the exact same thing. All of them are legit ways to find area. You're going to be doing 1/2 times 40 times 40 times the sine of 60. Alrighty, and it wants the exact value, so be careful, you can't put the sine of 60 in your calculator. Alright, this one we need to use our 30-60 triangle. 1, 2, square root of 3. The sine of 60 is going to be the square root of 3 over 2 times 40 times 40 times 1/2. Go ahead and simplify that. That is going to give us, let's see, 40 times 40, that's going to be 1,600 times the square root of 3, multiply by numerators, and then 2 times 2 is 4. So this is going to simplify to 400 times the square root of 3. Alright, wanted an exact answer, so you cannot use a decimal. Moving on the exponential growth worksheet, you had to do number 11. So we're still using this formula, A equals P times E to the RT power. They tell me that I'm initially investing $10,000. I'm putting in $10,000, so $10,000 is going to be my P. The first part is asking me how much I'm going to have after 2 years. So I'm looking for A. Remember, E is not a variable, it's the number E. My rate is 5%. That's going to be 0.05. And it wants how long it's going to be after 2 years, so times 2. So this part doesn't involve any logarithms. This you're just going to put into your calculator. So 10,000 times, you're going to use the E button, which is the same as the natural log button, 0.05 times 2. And what am I rounding this to? To the nearest dollar. The nearest dollar is going to be $11,052. Alright, so that's the first part of the question. It also asks how many years to the nearest year will it take for my initial investment to double. So for the second part, I want to know how long, so I'm looking for T for my A to be twice of what I put in. So I want A to be 20,000. And this is going to be times E to the 0.05 T. So now I'm looking for time. First things first, divide both sides by 10,000. So I get 2 is equal to E to the 0.05 T. The variable that I'm looking for is stuck inside of an exponent. How do I get rid of that? By using logarithms, but you got to be careful. Alright, since I'm using E, I can't just use the common log, I have to use the natural log. So we're going to take the natural log of both sides. On the left, I'm going to have the natural log of 2. The natural log and E cancel each other out, and I'm going to be left with 0.05 times T. So now I can just divide both sides by 0.05. Put that in your calculator, the natural log of 2. Oops, make sure you close the parentheses, which is what I keep forgetting to do. Natural log of 2 divided by 0.05. And what am I rounding to? The nearest year. So I get 13.8, round up to 14. So 14 years is what it will take for my initial investment to double. And we also had to do something from the law of cosine. Sorry, I had to actually find my law of cosine worksheet. So now for the law of cosines, we had to do number 6 and number 7. So looking at number 6, in triangle BCD, so here's B, C, D, little b, little c, little d. Little b is 5, little little c is 4, and the measure of angle D is 60. We want to find little d. This is perfect for the law of cosines. Law of cosines, you need two sides of the included angle, just like area. So this is going to give me d squared is equal to c squared plus b squared minus 2cb times the cosine of d. Remember, your ends have to match. So I have to have little d on the left, big D on the right, and then everything else is the other stuff. So d squared will equal 4 squared plus 5 squared minus 2 times 4 times 5 times the cosine of 60. So d squared will be 16 plus 25 minus 40 times the cosine of 60. Cosine of 60 you can put in your calculator, but you do need to know these right triangles. Alright, cosine of 60, a over h, that's 1/2. So d squared is 16 plus 25 minus 40 times 1/2. So that's 16 plus 25 minus 20. 40 times 1/2 is 20. So 16 plus 25 minus 20, d squared will equal 21. So d is equal to plus or minus the square root of 21. We're going to reject the negative because you can't have negative length. So d is equal to the positive square root of 21, which cannot be simplified. So that is your answer. And last but certainly not least, number 7. We're looking for the length of a longer diagonal of a parallelogram. So let's draw a parallelogram. Alright, notice it didn't tell me that it was parallelogram ABCD, but probably a good idea to label. So let's see. We want the length of the longer diagonal, so that's going to be this one, so AC. If the lengths of two adjacent sides are 6 and 10, so there's 6, there's 10. And remember, in a parallelogram, opposite sides are congruent. So if AD is 6, then BC also has to be 6. And if AB is 10, then CD also has to be 10. Do I know if I need that right now? I don't know. But if I know it, put it in the picture. It helps. And then it also says that the measure of an angle in this parallelogram is 120. Well, obviously over here at A, that is way too small to be 120. So this will be 120. And if B is 120, then D is also 120. Fun fact. And I want to know the length of my longer diagonal. Now, if you look, you're probably saying, you expect me to remember all this in parallelograms? Absolutely not. Well, if you look in this parallelogram, by drawing the diagonal, we actually created a triangle. And not only did we create a triangle, we created a triangle in which I have two sides and the included angle. So I can use the law of cosines for this. My diagonal, I'll call it x. Alright, x squared is going to be equal to 6 squared plus 10 squared minus 2 times 6 times 10 times the cosine of 120. So x squared will equal 36 plus 100 minus, that's going to give me 120 times the cosine of 120. Alright, and I guess this is kind of a jerk move, but we do expect you guys to remember some stuff from geometry. Alright, you do need to remember these things about parallelograms, that opposite sides are equal, that opposite angles are equal, stuff like that. So this is going to be 136 minus 120. Now the cosine of 120, remember 120 is in quadrant 2, but it has a reference angle of 60. So the cosine of 60 is 1/2, but since I'm in quadrant 2, it's negative. So this is going to give me negative 1/2. So x squared is going to equal 136 plus 60, which is 196. And I'm pretty sure the square root of 196 is 19, 16, I don't know. Square root 196, 14. I was way off. Plus or minus 14. We reject the negative. So x is equal to positive 14. So that is how big this diagonal is. And that is it. Boom, baby. We are